So thanks to both of you for the exhaustive presentation about the two visions for the interaction between, or the interdependencies between the two communities. So to take the end of your presentation about more integrated RDNI project between the two communities through the clusters, what kind of project would you expect there? What type of cooperation would you expect?
Well, we would like to see really projects where the consortium includes the whole value chain. So going from the chips providers, maybe even materials providers, to the users like Nokia or Ericsson, if I dare pronounce it well. Anyway, those kind of users to be able to maybe set up proof of concepts, because of course we are not talking about final products in our projects, but proof of concepts of how all these pieces are integrated together and how they handle the various issues that were very much very well presented by Mohand about the seamless integration between the networks or the energy consumption, and how do you provide the necessary intelligence also at the edge. So these type of things.
Because I think it's an important point. So we had a joint sustainability call between all clusters, and that was the first call joined between all the 5 clusters. It was a large topic and very open focus, let's say, really just sustainability was the term. When you look at what is done today in trying to reduce the carbon footprint of telecom networks, you see that people try to switch on off some features and so on, but possibly those kind of projects would even bring things together tighter between not just switching on off equipments or switching on off blocks, but having directly an integration between the components and the management of the network, so a tighter link. What is your opinion on this?
So I think that the artificial intelligence will be one topic that could be that will allow to go beyond switching on and off seamlessly with automation. Yeah.
Okay. One of the possibilities that we see with this type of projects, bringing together the chips manufacturer and the end user, I mean the big telecommunications equipment suppliers, is that this would allow to have a, I would say, a holistic view of the whole chain of treatment and of all the network. So, and be able maybe to, instead of, looking at silos and each trying to, let's say, optimize in its own corner, trying to have a whole optimization of the question, for example, of energy consumption, maybe deciding which function should be implemented where, is the kind of questions that can be investigated in this overall project with the whole value chain, in order to have a better answer. It's always better, to have a global optimum than the sum of local optimums, and that's what this kind of project is allowing to do, I would say.
I think the new technologies that we implement is really a key driver in order to reduce the energy footprint. We saw it recently in this photonic service engines. So we were able really to increase the capacity, but in parallel, we have been able to save like 60% of power consumption of our systems. just by implementing this new technology. So new technology is a driver. The second one is, of course, the automation that will be able to really be in an environment where you can, let's say, assess your network. In the past, we have been more or less in a set and forget mode of our system. Now we are more and more working on what we call internally in NOKIA, the 0 dB margin, which means that we optimize the network in order to make it optimum in its real case. So I think it's also this aspect of networking and automation will be key. So some chips will be required for that as well.
We discussed that before we had the session. You know the topic of Open RAN. So just for Open RAN is not meaning open source RAN. It's really just defining very well and publicly defined interfaces between the blocks of the Open RAN, so including the RIC, the CU, DU, RU, and so on. Many people are trying to push in the direction to have the features and the functionalities being implemented in software on generic processors for many of those functions, to have them in the cloud and so on. But don't you think that you need more, like for those functions, a work between the ICT community and the processors, the chipset communities, to have a lower implementation of those features? Because from my knowledge and from what I have seen, you don't really gain in footprint, in carbon footprint and so on by doing that. So and the capacity is not really there. So what is your opinion on this, and what we could do in a joint call on projects on this?
You want to start? I think it's more or less linked to the previous question. Of course, Open RAN is like a new opportunity. I think the idea of the people, or at least the ICT community or the telecommunication service provider like NOKIA had an evolving opinion about Open RAN. So this is because there are so many stakeholders involved, starting from the web scalers that have been able to propose part, or would like to really go to till the radio base station in the cloud. I guess the cloudification will open new opportunity. It's an opportunity for the ICT industry because we could share like equipment among many parts of the network. But also it's an opportunity for the chips ecosystem to develop to implement new design. One of the critical aspects here will be the security. So we know that, for example, on the chips design, we will need to be able to anticipate some. I don't know if anticipate is the right word, but cyber attacks is really today a big concern for the telecommunication infrastructure. At least it is critical. So we wanted, from our perspective, to have some possibilities to make more isolation between different parts of the network, including, if possible, at the chip itself, which could be something that maybe reinforce the level of security.
Okay, so first of all, I'm not a specialist in in RAN, so in Open RAN, but my very broad understanding is that the idea is to move from let's say, a monolithic implementation to split it in various layers where with standardized and defined interfaces so that various suppliers can provide those various implementation of the network and still it be working. As you do that, I think, as Mohan said, you go back to the previous question of when you break down things, you get more flexibility on the one hand. You might lose, let's say, the view of the overall thing and the global optimum. And for me, so one of the advantages of working together between our two communities would be indeed to identify how we can still maintain local optimum who are very close to the global optimum and to define those, let's say, the interfaces and standardization, having this into mind. Then to go back to your point about security, this is definitely also a very important point for our community. By the way, there is one of the chapter, the transversal technology chapter in the strategic research and innovation agenda, which is addressing that, which is covering cybersecurity. And here there will be, I would say probably in the future also implementation of those cybersecurity elements, which will have an impact also on the hardware side. Thinking of the possibility maybe to develop specialized processor or accelerator engine to do post-quantum cryptography, for example. This is probably a research area that would be of interest for the community and could be part of the answers to the question raised.
Thank you for your answers. Any question from the room? I'm looking at you.
Thank you. Just Pascal Cho here from the UK. Just a quick question for Mr. Mohand. Because you mentioned the separation in the network, and really interesting because most of today's discussion is about the network integration. So how to draw a line between the isolation between networks and integrations between networks? What do you think?
It's a very good question. I guess that there are parts of the network that are more fragile than others. I have seen people, at least for the moment, the community is concerned in the access network to make sure that we have enough isolation, because it is identified in this area where the intrusions could happen. So I think most of the research, at least today, or isolation is concentrated in this area. Because of, as I mentioned in the architecture, because of the many subnetworks that are involved, and we see that traditionally we had only the CSP networks that our customers address. Now we see that the huge possibilities, at least for 5G, enterprise, industrial applications are offering, that we will need to, at least at the level of access, make sure that we isolate in order to allow the end users to have, a proper network.
No other question?
Thank you. Yeah, you mentioned sensing networks and how that might fit in earlier. Just trying to understand how that works. I imagine there's two sides to it. One is network optimization and real-time tuning. The other is how that gets passed up to the user plane and the applications. I'm interested in what applications you see for that sensing side of the future network and the component perspective of that.
So I already mentioned to the colleague one of the foreseen application. So we have, for example, for submarine, this optical time domain reflectometry, which is able to sense really inside the fiber where, for example, it is cut. Now we see that we have also some other type of acoustic sensing that we could implement. It could be used to, for example, to sense under the sea the temperatures variations. And some studies show that the global warming is also associated to some variation in temperature deep into the sea. So we could have many data that could really be brought from all those cables. And we have so many cables that are today used mainly for TikTok and other applications between the clouds, but we could use them for other type of, for sustainability, for example.
So, no other question. So, I want to thank you. Thanks a lot. And looking forward for the cooperation between the two clusters on a joint call with the support of the public authorities, of course.